Dear students, welcome to my YouTube channel. Here we are discussing module 4, which is curve fitting and statistical methods. We know that curve fitting is the process of finding mathematical function to satisfy the table of data. Means we have to derive the relation between dependent variable and independent variable. So in the previous session, we are already discussed about fitting a straight line in the form y is equals to ax plus b. Here, to fit this straight line for the table of data, we have to find unknown constants a and b by these two normal equations, which are derived in least square method. Least square method means the experimental points or experimental values, the difference between experimental values and our straight line or our drawn graph is very less or minimum at each point. So similarly, next concept is fitting second degree parabola in the form y is equals to ax square plus bx plus c. Here, to find unknown constants a, b and c, these three are the normal equations. So in the similar manner, next concept is fitting the least square geometric curve of the form y is equals to a into x power b. Here, to fit this curve y is equals to a into x power b, here also to find the unknown constants a and b, we have to derive normal equations first. For that, look at here, consider the curve y is equals to a into x power b, take log on both sides, we get y becomes log y equal to, here log of a into x power b can be written as log a plus log x power b. Log x power b can be written as b log x. So we get this equation. Here log y can be written as capital Y equal to log a can be written as capital A, plus in the place small b we can replace capital B. Log x can be denoted by capital X. So we get line or equation y is equals to a plus bx. This equation is in the form of straight line. So the geometric curve of the form y is equals to a into x power b converted into the form of a straight line. We already know how to derive normal equation for the straight line. So just write down the reverse form of this equation, a plus bx equal to y here to derive normal equations. A plus bx equal to y. Just reverse of this straight line, a plus bx equals to y. Take summation on both sides. Here a is, we have to treat a as constant. Here is a into 1. So a into summation of 1 is n. N means number of values given in the table. Plus here b is constant into capital X. So summation of x plus, equal to y here. So summation of y. We have to apply summation throughout the equation. And for the second equation, multiply x. To obtain second equation, multiply x to the above equation. A into x, we get b into x square plus x into, equal to x into y. Apply summation throughout the equation. So here a into summation x plus b into summation x square equals to summation x into y. These two are the normal equations to obtain unknown constants a and b. Let's see one problem on this concept. Fit a least square geometric curve of the form y is equals to a into x power b for the following data. Here this is the table of data given here. Right. To fit the given curve, first we have to derive normal equations. For that, consider given curve and take log on both sides. Here log y equal to log a into x power b. Log of a into x power b can be written as log a plus b into log x. So we can denote by capital letters, call it as equation 1. This equation is in the form of straight line. So it is very easy to derive normal equation for straight line. Just write down the reverse of that equation, a plus bx equal to y. Apply summation throughout the equation. First here a into 1. Here we have a into 1. So a is constant, summation of 1 is n, plus b into summation of x equal to summation y, and multiply x to the above equation. A into x plus b into x square equal to x into y. Here x into y. So apply summation throughout the equation. A into summation x plus b into summation x square equal to summation xy. These two are the normal equations. Because here, observe here, there are only two unknown constants. Therefore, we have to derive only two normal equations. Right. To obtain these two normal equations, here there are some coefficients. Here is n. N means number of values. Number of values available in the table are 5. So n takes the value 5. And here is summation x, sum of values of x. X means we know that x equal to log of given values, small x values. So here is summation of x, summation of y, and summation x square. Here is summation of xy. For that, construct the table of data. In the first column, write down given values of x. The second column, write down given values of y. Here we need summation of capital X. So first we have to find the capital X. X equal to log x. Log of 1 is 0. Log of 2 is this one. Log of 3 is 1.0986. Log of 4, similarly log of 5 right on here. And find out their sum. We get summation of capital X. Similarly, y values are here. Find out the log of y values. So it becomes capital Y value. So log of 0.5 is this one. Log of 2 is 0.6931. So log of 4.5, log of 8, log of 12.5 is this. So these are the values of capital Y. So find out their sum. We get 6.1092 is the summation of Y. Similarly, here we need summation of x square. For that, square the values of x and write down here and find their sum. Similarly, find out the product of x and y, write down here and find out their sum. Substitute these values, summation values, into the normal equations. For example, here, first equation, a into n. N value is 5. So a into 5 can be written as 5 into a plus b into summation x. B into summation x value is 4.7874. So 4.7874 into b equal to summation y value, the RHS. Similarly, substitute values into the second normal equation. We get two simultaneous equations in terms of a and b. Here a and b are the unknown constants. These two are the linear equations. By using calculator, it means by using scientific calculator, we can substitute the coefficients of linear equation. We get the values of unknowns. So by calculator, we get value of a, this is value of b. We know that capital B means small b. Therefore, we can take capital B value as small b. But capital A is log a. To fit the curve y is equals to a into x power b, we have to find value of small a and b. So here, since b equal to small b, so capital B value becomes small b. But here capital A means log a, therefore a means e power a. By taking exponential on both sides, e power log a becomes a equal to e power a. Substitute value of a, capital A here, e power capital A value is 0.5. This is the value of small a. So a is 0.5, b is 2. By substituting into the given curve, y is equals to a into x power b. So this is the required curve, which is the curve of best fit to the given data.